Hey viewers, welcome back to our channel. Hope you are doing extremely well. So today we are going to discuss another interesting question on the topic of binary tree, that is nothing but longest univariate path. So without wasting time, let's move on to the question and let's try to understand it. So in this question, we are provided with a binary tree. Let me create it. So 1, 4, 4, 4, 5, and here is one more 5. Okay, so this is a binary tree, and what we need to do or what we need to return in this question is that we need to tell the number of nodes of a path. Okay, number of nodes of a path having the same data. So there may be possibility you don't get it, but I'm trying to say. But let's break the statement and let's then try to understand. Okay, the first point is that in this question we need to find a path having the nodes value same for all the for all the nodes. Okay, so the first thing is that we need to find a path for path of a nodes whose values are same. Okay, so here you can see that there are different types of paths. So this is the one path, this is the one path, and these are the paths whose nodes values are exactly same. Here you can see that this path nodes values are 4, 4, and 4. Similarly here the value are 5 and 5. Similarly this single node is also a path, is also make one of the path whose node value is nothing but 1. But what we need to tell in this question, we need to tell the node value? No, we don't need to tell the nodes value. Actually, we just need to tell the number of nodes who actually make the biggest path having the same node value. So here you can see that this path have the 3 number of nodes, this path have the 1 number of node, and similarly this path have the 2 number of node. So what will return? We will return this path, this value, actually this 3 value. So I hope you get the question. What we need to tell, we just need to find a path whose nodes value have exactly the same value. And what we need to tell about this path, we just need to tell the number of nodes of that path. So that's all for this question. Let's move on to the understanding part, like how do we approach to this question. For that, let me again create a binary. Here it was 4, 4, 4, and here also it was 4, 5, and the 5. Okay, so 5. So now the basic approach, like how do we approach to this question. Here I'm like the first thing is that here in this question we are going to work in a post order. Okay, post order, that means at first we will make a call to our children, and while we are making calls we are expecting them some information from them. Okay, means the moment they start returning, the moment they start speaking to their parents, they will return some information to their parents, and that information is useful for that parent just because this information will help the parent to determine what it need to do. So let's move to the dry run and let's try to understand what information actually the children return all the time. So as I told you that here in this question we will work on the post order, means at first we need to call to our children. So the moment we call this node will call to its parent, that is it call this 4. Similarly this node calls to its parent, that call to its children, that is call this node. The moment we come to this node, this 4, it returns some information to its parent, that is it returns two information. First, what is the value of its children, what is the value of a node. Okay, so I can say that each children node tell its parent that what is its children value, that is what is its value. Along with the value of the children node, it also returns one more thing. That is nothing but the longest the height, or we can say the height or the length, the longest height or length of a path that exists till this node having the same value node. Okay, means it returns two value. What was two values? That is the value of that node, and along this value it returns one more information. What was that information? The information was what is the length of, we can say the length, breadth, or even the height. Not the breadth, the height. Okay, just because we are performing the the breadth first search. Okay, so length of the length of the path length of the longest path. Okay, not the path, length of the path having the nodes with same value, okay. We just need to tell means each node returns these two information to its parent. So this node returns such information to its parent. Similarly this node returns this information to the parent. The moment this information a parent receives from its children, what it does, it tries to interpret it and then take some decision. What the decision it takes, let's try to understand it. Okay. Sorry. So this 4 will return something like this. Its node value is nothing but 4, but the longest path that exists till now is 1, just because this path, this node is actually including itself, nothing else. Similarly, this node also returns something like this, that is 4 and 1, just because it is including itself, nothing else. The moment this information reaches to this 4, there are some cases that arise for this 4. Okay, there are some options to this node. So let's try to understand this option. The first option, that is, what happen if the current node, that is, I am taking this parent node as a me node, if that node value is same as the left dot data and same as the right dot data. Okay, if such information is same, means if that parent node has the same type of node in its left side and same type of node in the right side, what do? We need to update two things. At first, we update the length of that longest node. How do we update it? We update it with the left plus right plus 1. That is the maximum of left dot right plus 1. Why? Just because this time what is happening, we are assuming that we are taking the path that exists on the left side, we are taking a path that exists on the right side, and in that parent is actually including itself. Okay, in that the parent is actually including itself. Second thing, we need to update the height. How do we update the height? To update the height, what we do, we find the maximum of left comma right plus 1, and this way we update the height. Similarly, the second case that arises, what happens if the parent data is actually dissimilar from its left children and the right children? Means, let's understand it with for this one. Here you can see that this one children is nothing but this 4 and 5. So means this 4 returns some data to this one, and this 4 returns some data to its parent, that is this one, and this 5 returns some data to its parent, that is this one. And the moment it start returning the data, the parent comes to know that both of my children, that is this 4 and 5, have a different value node. Okay, as they have different value node, so I can write this: if me is not equals to left dot data, similarly is not equals to right dot data. If such a case arise, what I'll do, my height will become okay, the maximum length of that path will become 1. Why? Just because this time the parent is saying that I am creating my path itself, including myself. Okay, means a new path will be created from me. Okay, and I'm including in that path. Similarly, I can update the height, and also my height will become 1. Why 1? Just because there is only one node, that is this node. Similarly, the third case is very similar. Okay, if the data of me is equals to the left dot data, if the data is equals to the left dot data but not equals to the right dot data, if such a case arises, okay, if the node on which I was working, or if the parent node data is equals to the left dot data but not equals to the right dot data, or such a similar type of case, like if the me data is equals to the right dot data but not equals to the left dot data, if such a case arises, we need to handle them also. Okay, so let me write the workflow for these base condition. If such a case arises, what I'll do, I will update my length of the path with left dot height plus 1, and similarly update the height with left dot height plus 1. Okay, and similarly for the right hand case, what I'll do, this time here I update my longest path with a right dot height plus 1 and the height with right dot height plus 1. Okay, so that's all for the explanation part. I hope you get it. So what we are going to do now, we are going to move on to the pep coding portal, and there we write the code. Okay, so this is the pep coding portal. Now let's try to write the code. Okay, so here let me increase the screen size, and here you can see we are providing the longest univariate path method. Now what we are going to do, at first we are going to create a pair class. So let me create it, public class pair. Okay, and it will take some parameters. First will be int data and int gist height, and let me create its constructor. It is int data int height. pair in data and height. This dot data equals to data. This dot height equals to height. Let me copy this and let me create another constructor. That is okay. So this constructor was not taking the parameter. It was taking only one parameter, and here was updating the height with a 1. So here we have completed our pair class. Now let me complete this method, that is this longest univariate method. So here what we'll write, first we'll check the base condition if root is null or not. If it is null, what we'll do, we just return 0, and then we make a call to the method, that is func method. It will take some parameter, that is the root, and at last it will return the max minus 1 value. Okay, so let me complete this function, that is the pair func method. Let me create it and complete it. So I will create it. At first let me create a static variable, that is the pair answer or max variable. Okay, so public static int max equals to 0. Now after that, public static pair func tree node. Now moving forward, if you encounter the base condition, if node is null, what we'll do, we will create a object of this pair class, a temporary object, that is the new pair, and with some value, that is the integer dot main value. Okay, and with 0. Now at last I will return this space. So that was the base condition. Let me make a left call with a pair left, right call the pair right, and let me create my own object, that is the new pair node dot val. So let me complete the upper calls. Here I was doing the node dot right call. Yeah, we were taking node. Yeah, node dot right call. Similarly here, node dot left call. Func node dot left call. So we have completed the calling part. Let me check the conditions. Okay, let me make at first condition, and then I will just perform copy paste for the remaining condition. First condition was my data, that is the current node data, is same as left dot data, and me dot data is same as right dot data. If such a case encounter, what we'll do something. Okay, let me write the other condition, that is if I'll also do here something. If here also I perform something, here also there is some condition within which I will do something. At last I will return the null. Why are we returning the null here? Just to handle the remaining base conditions, because in all the conditional statements I will return something. Okay, let me at first copy this line, Control C, and let me update it. Okay, here my data was not equals to the left data, and my data was not equals to the right data. Here my data was only equals to the left data, but was not equals to the right data. Here my data was only equals to the right data, not equals to the left data. So those were the conditions. Let me write some code within it. So I will update my max with the mat.min, mat.max actually, mat.max of max comma left dot height plus right dot height gist height plus me dot height gst me dot height. So it was left dot height, right dot height, me dot height. So I have updated the max. Similarly, me dot height will become 1 plus mat dot max left dot height right dot height left dot height and right dot height. Now I have updated the me, and at last what I'll do, I'll just return me. So me, that is the current node. So let me copy it for the remaining part, and I will update it according to my requirement. Here also. Same. Now let's work on the second part. Here the max get updated with mat.max of max. Again mat.max of left.height. Again mat.max of mat.max of right height. It was not me dot height, it was 1. Okay, and me height was nothing, so my height will not get updated, and I just return me in this case. Similarly, also height, when it become left dot data, me height was at first, let me update, plus equals to, there was no mat dot max, it was get updated with left dot height. Okay, and this max of the left data get updated. In this case, max get updated with mat.max of max of mat.max of something. Let me figure out what was something. Me dot height and right dot height. So let me erase here left dot height, me dot height and right dot height. Similarly here also, let me copy the same thing. In this case, me height get updated with right height. Okay, and max of mat.max max right height and me, that is here it will be left height and me height. Okay, that's all for this code. Let's try to run it, and if we encounter the error, let's try to resolve it. So our first error is nothing but math.max no suitable method found for max of mat.max left dot height max left dot height plus 1. It was not plus 1, actually it was, there it is, it was I think in the first it was not plus 1, it was only 1, comma 1. Okay, now the second error, it get accepted and we get 0. Let me figure out why we are getting 0. So yeah, we are getting this error just because here we forget to update the me dot height plus equals to right dot height. Now let me correct it, and now let's try to submit it. See, it is accepted. That's all for this video. I hope you get the content of this video, get the intuition of this question, and I believe that now you are able to solve this question. So that's all for this video. So let's meet in the next video. Till then, stay safe, stay healthy. Don't forget to hit the like button, share it with your friends, and subscribe to our YouTube channel.